Hi, this is Katie, and in the Learning Module 3 for Chapter 2, we are going to do a Code With Me video to understand how to structure our programs. We're going to work with data today. Now, if you're in another teacher's class, remember they might not use the concept of learning modules, but the Code With Me video that we're about to cover covers Chapter 2 in our textbook on using data. So I'm going to close my window, and we're going to launch JGrasp. And there's my messy desktop. And we're going to create Code With Me too, so I'll call that appropriate. Now, this is helpful. Here's my basic code that came up automatically. That was in, well, I'll leave it alone. I'm going to close everything. Here's my window. Remember in JGrasp it has a window where it shows your recent programs, and I'm going to do a new one. And this one I'll call CWM3 assignment, Code With Me 3 assignment. So I'm going to do File, New, Java. I'm going to hit Save. And it points to where I want to save my folders automatically. So Code With Me 3 assignment. And remember, it will automatically apply your extension and of .java, and we're going to do DOS formats. We'll hit Save. And I am going to do my basic setup. So remember, before we go into Chapter 2, remember we put who we are. So put your name. We put our date. Today's the 11th. But it's going to be assigned in the 12th, or if you're using a different semester, put, if you're in the winter semester, use the date for that. And a description of the assignment. Code With Me 3. And I'll add a more detailed description. Okay, one of the major concepts in Chapter 1 talked about these three programming concepts. We have sequence, we have decisions, and we have loops. So in this chapter, we're still focusing on sequence. And the sequence of things that we're going to follow is, 1, we're going to declare any variables that we're using. And then next we will process any inputs, so take in data, which is inputs. And then our third step is to perform any calculations. And then the fourth step is to process or display your output. So when you are reading through this chapter, when you're doing the assignments, that's not the Code With Me, it's a Learning Module 3 assignment, follow these 4 steps inside of your main function or main method. We're always going to declare variables, take in data, do calculations, and process outputs. It's the major flow of any program that we do. So to begin, we're going to set up our basic structure. I'm going to add just a line here to separate my header from my actual code. And we can make this a little bit bigger. No, right here. I'm going to just move that down right now while I code. And I'll move this over a little as well, so we have more screen space for you to see. Okay, so we're going to set up our public class. So remember we do public class, and then our class name has to be the same as what our file name is. So CWM3 assignment. That's what I called mine. If you called your something different, your file something different, then name it appropriately. and then open, and I'm going to go down end of class. Then we go back up and we put in our main, public, static, void main, string, hard brackets, args, brackets, open main, close main. Okay. If you need an example, go back to the About Me program or your Code With Me 2. You have your basic structure. This is what you need to start every program. And then at the bottom, I'm going to put in my documentation so I don't forget to put my sample output, and I'm going to use this method. So I'll leave a note here that says sample output, below. And then when I run my program, I'll go over to my iOS, I'll grab my output that comes up on the screen, and I'll paste it right here. Remember, this is the file that you submit for Code With Me, and the Java file is what you submit for grading. So there's our basic setup. Again, copy this if you want and start out all programs the same. Now, my line numbers and my formatting went away, so I'm going to add those back in because I think it's more useful to see, especially as you're watching the Code With Me. And I believe that was under View and then line numbers. And then you can do Control-A to select the code that you have, and then View, Generate CSD, and it will format it. I can't remember if I ever looked up what the CSD stood for, but it formats it so that it's easier to follow. And we're not using a lot of brackets and curly braces in this chapter, but as soon as we go on to loops and decisions and writing our own methods and classes and objects, we're going to have them all over the place. So the point of formatting them is that you don't end up crying over something that's missing. And I'm making fun of me because that's what I do when I can't figure out my code. But it gets easier. Okay, so we are ready to code. Now in main, we have the main structure, and this isn't specifically listed in Chapter 2, but you'll notice all of the programs are set up the same way, where it's, as you're looking at examples, the first thing it does is declare variables. Well, for example, I'm looking on page 78 of the textbook. There's a class called getUserInfo. The first thing that they do is they declare two variables, and we'll just talk about what that means in a minute. And then it does our input, where it asks for those two variables. This particular program has no calculations, but say they wanted to add 20 to the age. They would say future age equals age plus 20, and then it does its output. So it doesn't say, the book doesn't specifically say declare variables, do your input, do your calculations, do your output. But if you notice in the flow of every program in this chapter, that, and actually a lot of the future programs, that's what goes on. So I always make a note when I'm coding, and as a student, this will be helpful to see where do I put things, especially when you're looking at, say for example, you're looking at Learning Module 3, the Chapter 2 assignment, and you're creating a pedometer calculator. Well, the gist of the program is explained, but then it says, okay, here are your inputs, and then here are your calculations, and here are your outputs. So yes, you have to determine what your variable names are, and you have to determine how to do the calculations, but the flow is going to remain the same. So I'm going to do declare variables here. Remember, all of our code for now goes inside main. Then I will process my inputs, and I'll just put in some spaces. Remember, this is all white space, so it doesn't matter at this point how many spaces you put in. And we're using documentation right now, so it doesn't have to be keywords. And step 4, Step 3 is our calculations. And let me see if I can. Well, there are some. Okay, well, there's an example on 131 to compute commission, but this program doesn't do input. I'm looking for all 4. Our programs will do all 4. We'll do a sample program together that does all 4, and then we will, here's something, and then we will, the assignment you'll do all 4. Maybe we'll come across one as we're reading through the chapter. So the step 4 is display or processor output with like printf statements or print statements. Okay. One thing I want to point out why we mentioned print and printf, even though we don't know what it is yet, in Learning Module 3, Chapter 2 assignment, I want you to format your output so that it's easy to read and uses decimal places. So in this particular program, say you lost 552 calories and a half, so 550.5. I want you to display it with a 0.5. So you can use a function called printf, and this is explained in the Appendix C, page 1010 of your book on rounding numbers. If you don't happen to have the Appendix C, if you bought a squished version of the book, then send me an email and I'll shoot you, or I'll post some links on how to use printf. We're going to use printf a lot before we even get to that topic in the chapter. So I wanted to point this out right here. It's quite important. Okay, so let's talk about variables, or start talking about the beginning of the chapter. Now this chapter's long, and I want to keep the Code With Me video to about a half hour, and I've already used 12 minutes. Yeah, that's not going to happen. I'll try to keep it to 45 minutes. And when you're doing the code with me, it'll take you longer because you'll pause and start again. So there's a lot of material in this chapter. It's over 50 pages. You have to read the chapter. I can't read it for you. I can't read it to you, but I want to point out the important things in this chapter. Read the chapter. The first thing where it talks about variables on page 52, we're going to come back to constants, but it talks about the concept of what a variable is. A variable is just a place in the memory that we need to store value for. So if I want to store my age, I would create a variable called my age. If I want to store, for example, you don't have to type this because I'm going to delete it, but if I wanted to store my age, I'd create a variable called my age. If I wanted to store your age, I would create a variable called your age. Oops, I always initialize my variables. If I wanted to create a variable called my name, I would create a variable called my name. Same with your name. If I wanted to calculate my total for something I purchased, I would create a variable called maybe total purchase. Something like that. So what it is, these are data places in the system of the memory that can store a value. And right now it's set to 0, so it stores a 0 value. But as your program goes on to inputs, it replaces those values. So if I had, if I had a box drawn here, right here, and it was labeled, it would be labeled my age. And right at the beginning of the program, it has a big fat 0 in it. When I get down the input, and the person in you as a programmer codes enter in your age or her age or whatever, it takes that place in memory and it replaces the big fat 0 with whatever the user inputs. So what we're doing with these programs now is doing interaction. So we're not just displaying things to the screen, we're creating places for values to be stored, which are called variables, and then we are taking in values from the user of the computer. So when we get to the input-output window, run IO down here, it'll stop and ask us for entry of data. And then we get to the calculations and we do something with that, and then we display our data. So a variable is just a named memory location that can store a value. Typically the values vary. It's a variable. Get it? But sometimes they can be constants, and constants do not change. Their tax is often used for constant. Or the final keyword, there's a keyword called final that's also described in this chapter, that these variables cannot be changed. So page 54, it explains the concept of constants. These are values that never change. And it talks about, like, tax rate is 15% always. Well, wherever this is. Pi is always 3.14159, and they round it, but that's what pi always is. So we would make those a constant by using the final keyword, and then the user of the program can't change it. But unless we're using a variable like taxes or something that never changes, even though taxes periodically change, we typically would just create a variable, whereas the value was initially set to 0, but it could vary based on whatever the person enters or whatever your program calculates. Okay, so we'll do that with our example that we're going to code. I'm going to delete, well, I'll leave that there for a minute. Page 52 shows shows your numeric and one other one, or two others, but it shows the primary keywords. There are different, these are called data types. This is the type of data that I intend to store in my variable. So in my variable called my age, I intend to store an integer, which is a whole number, no decimals. So I made my data type int. The book shows you int is a integer, a whole number, and it goes from, you can store a value from negative 32,000 and something to positive 32,000 and something. So it can be quite a large whole number. And then there are variations. A short is half the size, a long is twice the size. And the same with the data type double. I always use double and not float. The book, I noticed, uses float a lot, but they're both the same. Doubles are used when I intend to store a decimal value, or also called a floating point, a decimal value. That would be a double. So integer you've probably heard of, maybe not floats or doubles, but those are when I want to store a decimal. Anytime I'm using money, total purchase, that would be money. Income, that's money. Anything that is a portion of something that stores or needs to have the potential to store a decimal, that has to be a double or a float. And I tend to use doubles rather. It's just larger, and sometimes the compiler will give you warnings if it's a float. So I use that. The Boolean data type stores a true or false, and we will use this. And the char stores, back in page 52, the char stores one letter. We will use this primarily when we do loops and decisions. We won't in this chapter, even though it's explained. Other things with variables. Oh, here's another data type, string, and it doesn't come up as a recognized data type, so it doesn't show you it doesn't show up in color, and it doesn't in any compiler I have ever used. But it is a data type, and a string stores a series of letters. So char stores one letter, such as Y or N or K or P. Those are letters, right? Sorry for, that was I didn't need to explain that, but I did. And a string store is a series of letters such as K-A-T-I-E. Or a sentence, which is, again, just a series of letters with spaces. So strings we'll use in this chapter, we'll use with both of our Code With Me and the actual assignment. Strings are introduced later in the chapter. I think the first reference is on page, it should be around 76, but it starts talking about this scanner class and using strings and string builder. There's a little different input than using floats and doubles and integers, but they're necessary. So we often need to take in a name or something like that. So we'll work on that today as well. Strings are pretty easy to use in Java. In some other languages, they're a little bit more frustrating, but they're pretty easy to use in here. Okay, going back to page 53 of the textbook. So I know I've talked for a while and I'm only on the first page, but these are the important concepts of the chapter. So we have understand what a variable is and the major data types. What you can do, a note here, most of my variables are strings, ints, or I don't want to use the S, string, ints, or doubles. And those are the keywords for most of the variables. A integer cannot store a decimal, but a double data type can store a whole number. So just because total purchase is a double, it doesn't mean that it has to have a decimal. It could also be just 199 and not 199.99. So those are the major data types. Typically you pick from those three: int, string, double. When we get into loops, we'll do chars too. And Boolean, the Boolean data type, B-O-O-L-E-A-N, also described in the chapter, that stores a true or false value. And we will come back to this and use this when we do decisions, because we'll use that. And loops, we'll do that a lot. Okay, page 53. This talks about the rules for declaring a data type and starts into the rules for declaring variables. There's camel casing talked about. I saw it somewhere. Flipping through. Okay, let's kind of go through some of these concepts pretty quick so we can start coding. But page 53, important things to pick out when you create a variable. You have to give it a data type. So again, that's the step here, or right here. Give it a data type. The other thing that you have to do is name it. And one of the common methods is called camel casing. And there are other methods, and they are in bold in this chapter. I don't know where they are in the book, I'm sorry, but you'll come across it. The major method that's used by most programmers is camel casing. And what camel casing is, you'll see it in a lot of examples, but they'll use, like I did here, I have two words called my age, and I capitalize the second word, the first letter of the second word. That's camel casing, just like here. And we do that because it's easier to read when you have a long variable name. It's easier to pick out the two words. And then you can't have spaces in variable names. Or special characters. So you can use an underscore. And you'll see that a lot, like this is an underscore, so underscore my age, something like that. Or it might separate the two, so my underscore age, something like that. But you can't have a space in variable names. names. No spaces in variable names. Huge rule. The variable should represent what it stores. So I didn't call my variables variable 1, variable 2, variable 3, and variable 4. I named them what they are. My age, your name, or your age, my name, and total purchase. And then also, most of our statements end in a semicolon. A note on initialization of variables, which the book talks about, where, again, read the chapter, but the book talks about it, where you can initialize values with certain, or variables with certain values. So, for example, on page 54, my age, 25, but I don't want to be 25 anymore anyway. Your age, 19. So you can initialize them to certain values, and then if it's not going to change, you can make it a constant. If it might change, don't make it a constant. But values can be initialized to anything. Now what I do, because I'm an old school programmer, is I always initialize my variables to nothing at the beginning. And you don't have to. You could just say my age. You don't have to in Java. You have to in some languages, which is why I'm in a habit of doing that. But you could just say int my age. Then when you get down here to input, you replace that nothing with a number. Here, I start off and I have that variable set with 0, so that big fat 0 again. And then I replace it down here. And I do that so I kind of wipe out the value of the memory location that was stored in there previously. Chars are initialized with single quotes. Again, we're not using that in this chapter, but it's discussed in here. And then strings are initialized with double quotes, and it has a space. You have to have a space between that. You could also do a value. Kitty value. Oh, I'm tired. Vander, Meer, you could type in a value, like my actual name, or just leave it blank so that you can come down here and enter it. So again, you don't have to initialize your variables in Java unless you know it's going to be a constant or a fixed value. Those are explained on page 54. Those are your major rules. You can't have a number in your variable name, but you can, you can't start it with a number, but it can contain a number. So you could do like my name 1, my name 2, my name 3, but you can't do 1 my name, 2 my name, 3 my name, using the digit 1. Okay. The next concept on page 56 is the concept of scope. And we will you read about it, you might be asked questions about it, but when we get to methods in classes and we create our own methods, we'll come back to scope. For right now, we're going to put everything in main right here, so only main can use it. Let me jump ahead in the book. On page 62, it talks about the data types. Remember I said, ints are 2.1 million or billion. So those are the values that ints and shorts and bytes and longs can store. You can see the numbers are quite large. The same is true with decimals or doubles, so that's probably on page 69. So because it's an integer, it doesn't mean it can only store one value or one digit. It means it can store one whole number between negative 2.1 billion to positive 2.1 billion if you use an integer. There's also something called unsigned or signed. Our variables are signed by default. They're signed by default. I don't know if this is in the chapter, but that means it can only store by default it can store a positive and a negative value. If you only wanted to store a positive value, it could go up higher. So you can make it unsigned, and then it could go from 0 to 4.2 or 4.5 million. So it still has the same amount of space it occupies in memory, but it won't allow you to store negative values. Okay, that is explained in Two Truths and a Lie on page 63. It talks about positive and negative values. The Boolean data type, you know, these, before we go into Boolean, we're going to code something different, but these you do it programs are very useful. So if you also want to do like the you do it on 64, that will help you to understand. Boolean data type is on 67, and this uses a true or false value, and we often use these in comparisons. So if my age is greater than 30, almost at 20, if it's greater than 30, then set something to true. So there are examples in the book, but we're going to come back to that when we do decisions. They're more appropriate in that chapter, I think. Floating point data on page 69. This is where it talks about the difference between floats and doubles. And I typically use double. The book uses float a lot, but you'll notice too that it uses the letter F after a number, as in 4.87F, and you could also use D for double. So I'm using double, so I might use a D. And what that means is it stores it as a double or a float by default. And that helps us round things. It helps us make things more precise. So we'll talk about that when we cover printf. Let's see, next concept, char data. Let's check the time. Okay, I had to take a break for a minute, which you wouldn't notice, but I had to check on my dinner. Okay, page 70 talks about the char data type, and that stores one letter. We're going to come back to that when we do decisions and loops. Read about it now. There may be questions on the quiz about it. The quiz I just used for my test bank. Page 76. Oh, we have so much more to cover. I'm going to get moving on this because I've already wasted my 45 minutes. But I don't get to see many of you, so I want to talk about these things that are super important. Page 76 is how to use the scanner class, and this is how we do input. So let's start coding. Let's stop talking and start coding. So I'm going to erase the stuff I was talking about and just leave the basics. I'm going to declare my variables, do inputs, calculations, and outputs. And I want to code the program that is in the back of the book on page not the back of the book, the back of the chapter on page 113. We're going to, with the Code With Me video, we're going to do this program that is miles to feet interaction, and it converts miles to feet, or feet to miles in the distance between one point A and point B. And we need to do the interactive one, so instead of assigning a value, we're going to ask the user for the input. And then I want to set it up so it's going to be similar to how you do the assignment, which is the purpose of Code With Me, so you'll be ready for the assignment. So I want to set it up similar to that. So we're going to make some modifications to the program on 114. 4B is what we're doing. 4A and then converting it to B. But I want to first create a variable. It says create a variable that holds the number of feet in a mile. And this doesn't change, so that could really be a constant. So I could do, but I won't. I'll just leave it as a integer. Feet in mile is what I would call that, and I'll set that to 5,280. Now, when you put in a number like that, you don't put in the decimal. That will cause an error. So you don't say 5,000 because now it's read as a string. It's just 5280. I'm going to comment this. How many miles in a, or how many feet in a mile? Feet in a mile. Oh, with it today, I really am. And then we wanted to clear a variable that represents the distance in miles between point A and point B, or your house and your uncle's house. So I don't want to give that a value because I'm making it interactive, but how many miles? And I am going to use a double. I might need to change feet and miles to double because of my calculations, but distance you often say is 3.5 miles. So I'll just call this distance, and I'm going to set it to 0, and this is going to be an input variable where the person says how, what's the difference. I also want to show you how to use string. So I'm going to, I want to create a variable called, I'm going to just call it point A and point B. Where are you coming from? And this will also be an input. And string point B. This is where you're going to. So this would be, my house to my uncle's house, or my house to my aunt's, or my house to the store. Where are you going? Where are you going? And so the program, let me read this again. Compute and display the distance in your distance from point A in both miles and feet. So this, we need to display, or we need to create a variable called, what would you think? We need to, because I don't know if feet and miles is a good name for that. I'm going to change this. I'm going to not set that as a constant. I'm going to just use it as part of my calculation. This will be similar to your assignment where I say there are 2,000 steps in every mile. I'm not going to, I could create a variable 2,000. Well, I guess we'll leave it. But I need to create another variable called distance. And I'm going to do distance in feet, and I do it right. And then I'm going to change this one to distance in miles. And my distance in feet is something that I am going to calculate. And that was an interesting word. And the distance in miles is something that I'm going to input. But in order to calculate distance in feet, I need this value, and I'm going to multiply it by this value. So, for example, let's walk through. Part of understanding programs, it's like part of a story problem. So you have to figure out what the client wants. Now, when you get to your assignment, here, I am the client. You need to figure out what I want. So when you read this, if there's clarification that you need to ask me. Send me an email, shoot me a text, call me. Say, what do you, pretend that you are the programmer, and I am paying you $1,000 to write a program to, I'm not going to pay, by the way, but to calculate a pedometer calculator for me. And you want it how I want it. I have a lot of students, but I'll answer your call. If you have questions on what version A of this pedometer calculator should look like, call me. That's why I'm here. I don't want version 2. I want version 1, and I want it to be perfect. So that's the assignment, and it's similar to what we're doing in question 4 of 113. Now, why I'm talking in circles and going, well, what should I name this? It's because I'm coding without doing a, oh, hopefully I'm not talking in circles really, but it's because I'm coding without doing a flow chart or a pseudocode. I'm just starting to code, and I'm trying to figure out what my inputs and calculations and outputs are. And I want to name my variables something that they represent. So this first variable represents, I really could even do more, how many feet in a mile. And that's really clear, you know, which is what I put in documentation. The problem when you name a big, long variable like this is if you spell it wrong later, you're going to get a syntax error. I'll leave it because I'll copy and paste. But this is the distance in feet. Distance in feet from A to B, and then this is the distance in miles from A to B. But the distance in miles, when you read the question, that's an input. Oops, student is texting me now. Okay, that's the input. So assign convert this program to an interactive application where instead of assigning the distance in miles, the user is going to input. So that's why we're not assigning 8.5. And then we're going to modify to do our strings, so we know how to do that. All right. Those are my variables that I need. When you do the assignment here, figure out what variables you need to give. Actually, let me help you because this is just our first program. And this will test whether or not, or tell you, hey, it's probably a good idea to watch the Code With Me videos because it helps me with the assignment. In fact, that's one of the first questions I'm going to ask you if you ask me about this is, oh, did you do the Code With Me? But, okay, when you are in Maine with the, when you're in Maine with the Chapter 2 assignment, remember, the first thing you do is your variables. Step 1, variables. And what variables might you need for this program? Write a program that calculates the number of calories a person will lose by walking at a slow pace for a mile. The dietitian only has the pedometer. So a client, a client is going to a dietitian, and they've walked around all day with a pedometer calculator. And at the end of the day, the pedometer calculator says, you've walked 5,342 steps today. I don't know if that's normal or not. What your program is going to do is take that input and figure out how to calculate how many calories they lost. So for every step, or every 2,000 steps is the mile. So it would be, you know, you would have to create a variable for number of steps they took. We need to calculate how many miles they walked. And again, this will be something you calculate. This is number of steps. This is something you ask the user to input. There are other things here. Allow the user to enter in the patient's name. Come back, sticky note. So string name or patient name, and that's an input. It says so right there in bold. The day of the week, weekday that it's on, input, and the number of steps taken right here. Then it's going to calculate how many miles were walked. Oh, and it's going to calculate how many calories were lost. So again, double calories lost. And that is a calculated variable. So that would be what you would do in step 1. When you declare your variables, that's there. That's all I'm going to help you with on this assignment. Your next step do your inputs, then your calculations, and then your outputs. Oh, I'll help you with one more thing. When you calculate, there's two things we're calculating. First, it has to go in order. So first I need to calculate how many miles I walked or your patient walked. That is calculated as the number of steps divided by 2,000. Because for every step, for every 2,000, it's a mile. So again, if I walked 5,342, that's the number that's on my pedometer at the end of the day. And I divide that by 2,000. I have walked 2.671 miles. So next you calculate how many calories were lost. Use your right variable names. And that would be the number of miles, not 2.671 because it varies, but it would be the actual variable called miles walked times 105. Right here, a person loses 105 calories for every mile they walked. Then you know, for every mile I walk, I lose 105 calories. That's walking at a slow pace too. So that's the ideal of this program. Again, the flow and what we're going to do with this program. And okay, I've met my 45 minutes, so I'm not going to speed up a little bit, but I'm going to shoot back. I was on page 113 in the textbook. I hope you're enjoying this because my voice is starting to hurt, but I've been sick as well. Well, now I got a cough. Excuse me, sorry. Sorry for coughing in your ear. Back in the book to page 76, and this is a super important chapter, that's why we're spending so much time, but on page 76, it tells you how to use inputs. 76 and 77 are probably one of the most important things in this chapter. The first thing we have to do is create an input device variable, and you can call it whatever you want. And we also have to include system.in. So your two main examples is that when we do input, I'm looking at page 78 where it gives you an example of how to do input, but we have to add something to our major class. At the beginning of this program, very top, we need to import import java.util.scanner with a capital S. And just my headset. This allows us to do input, which is user interaction, which is what all of our programs will do. So we need to have this on every code we start. Must have from now on. Okay? We always import this. This is a part of Java that allows us to input data. Now, inside of main, you have, before you do your input, so I usually put it at the beginning of main, must have for input 2, or as well. So you have to create an object. So we use the scanner class, so we say, which we've imported up here into our program. The concept's explained in the structure, but you need to understand it. So we're doing scanner. And then we're going to create a device, input device, and that's just a variable or an object. And then you can call it whatever. I always call it input or input device. And then equals new, which is the keyword, scanner. And then what we're doing is we're going to use system.in, which is part of that class. Oh, I have two N's here. It's just one. I'm sorry. For input. So there's two new things. You need to have this line and you need to have this line. What's this line? So in my code 10 and 17 although your lines could have different white spaces. That prompts the program to stop so the user has interaction. Page 77, this is how we do input, and this is, again, one of the most important things in the chapter. If we're entering a double, we use next double. If we're entering an int, we use next int. If we're entering a string, we use next line. Those are the three major data types that I'm going to use. So those are the three major methods I'm going to use in my programs. And there's a problem with next line that we need to talk about in 79. Okay, so let's start. Let's start with where are we going to? So I'm going to ask a question. So system.out.print, and I'll just use print, not print ln, but I'm going to say, where are you coming from? They could put my house, whatever. And then those are, we learned system statements previously. But we have to ask a question. So I'll put that in the form of question. Although remember, what you put in the quotes is a string literal and it doesn't matter. I'm going to next store that into a variable name, and I'm using a string because that's what point A is. So I'll say point A equals input device dot next line. Like that. Now, I haven't done anything else, but let's stop for a second and see how this runs. So I'm going to go build, compile. Okay, I have a syntax error. Oh, you know why I have a syntax error? I didn't include the string header file. Let me, where are you coming from? String point A. Let me see real quick. See, are you happy that I get syntax errors? Both with string, cannot find symbols string. Oh, you know, it's a capital S. See? Case sensitive, I even did it. At least I didn't start crying. Capital S for string, capital S for string. Again, it still doesn't show up as a keyword, but let me build, compile. Oh, good. If you have syntax errors, do what I just did and try to fix them. Oh, let me clear. That was my old one. I'll compile again. Okay, I have no errors now. Okay, let me run. So I'm going to go to build and then run. Over here, where are you coming from? It stops. My house. And then I hit enter. And then it goes on with the program. So what this part of our code, go back, what this part of our code does is it stops our program so we can do input. A few minutes ago I said, oh, we need to talk about what's on page 79. Okay, you can encounter a problem when you use one of the numeric scanner class retrieval methods or the next method before you use next line. There's a fix to this, but it's kind of annoying. What you don't want to do, if you accept the numeric input prior to a string, the string input is ignored unless you take special action. The special action is on page 81. What the special action is that highlighted on figure 2.21. It says, okay, because we're taking in what is your name after we take in what is your age, if you do that without that highlighted line there that says input device device.next line, it'll skip your input. The compiler does it. Or the language does it because it needs a space in memory. So what we need to do is make a place for that character, or consumes the enter key that follows the input of your age. So that, make note of this page 81 and that fix. And if your problem doesn't stop, or your program doesn't stop when you think it's going to, you have to use that line. So I'm going to, let's code without that, because it only happens if you do an input before a string. Well, look at here. First, I'm doing my inputs of my strings, and then I'll do my number. But if you did it the other way, then you'd have to include it. So system.out.print, and I want to ask here, where are you going? And then I'm going to store that into point B, and I'm going to do point B equals input device dot next line. Let me test. So again, I'm going to compile. Now that I have some interaction, I want to make sure my program's running as I'm going. Sounds like there's a big tractor outside. There might be. Okay, where am I going? Or where am I coming from? My house. Where am I going? My son's school. I got to go there pretty soon for curriculum night. My program's over. Okay. That's great. We have input. We have interaction. We are programmers. I'm still not paying you $1,000 for this program. All right, what's our last input? How many feet in a mile is our constant? We know that. How many miles is it? Because we want to, for some reason, I want to know how many feet it is, in case I ever wanted to measure it out with a measuring tape. So I'm going to ask that question. System.out.print, how many miles is it from point A to point B? And I am going to say, I'm going to store that in my variable for distance in miles equals input device dot next what? We're going to go back to that very super important page on 77. And we are going to use next double, because look at distance in miles is a double. So I use next double. I use next line with strings, and I use next int if I were inputting how many feet, but I'm calculating, or I'm just using that variable. So that's the end of my calculations. Or that's the end of my inputs. I only have 3 things that I want to enter. Compile again, should be fine. I'm going to run it. I'm going to say my house, or I'm coming from GRCC, and I'm going home. And how many miles is it from point A to point B? 10. Whoops, not K10. 10. Okay. Program's still working. Let me show you something cool before we go on to our calculations. Okay, this is how my output displays. This is not only something cool, but it's something explained in the chapter. And it explains concatenation and conversion. You want to read about that. But you can include, so instead of saying from point A to point B, you can include something like system.out.print. I gotta check that noise. Hold on 1 second. Okay, I figured out the noise. They're patching the driveway next door. So it's a big machine. Okay, I was showing you something cool. So I was going to show you concatenate. How many miles is it from, I'm going to end that, and I'm going to use the plus sign, and I'm going to say point A plus, use another space. How many miles is it from, so it'll say Meer or my house, to space plus point B, and then I have a plus, and then I want to ask my question. Let me run this and show you what comes up now. Okay, we're still running. Okay, where are you coming from? GRCC. Where are you going home? How many miles is it from GRCC to home? 10.5. Enter. My program ends. So what I've done, I've changed a generic point A to point B to actual values that we already entered, and it looks a little bit better. The program looks easier to follow, and you'll notice I want to format it so it's a little bit easier. So I have home, question, and there's no space there. I'm going to put a space right there, and if I didn't have a space here, this would be all, this space here, this space wouldn't be there, but I want a space there. I want it to read nicely. So that is concatenation, and with print and print LM, or print LN, excuse me, you can do that. All right, let's go on our calculations so we can finish this up, because this is going on too long, but I know you're learning great things. Okay, we are calculating distance in feet. So my distance in feet, I kind of want that whole screen there. My distance in feet is going to be equal to my 5 point, that would be multiplication, right? Distance in miles, whatever I entered. Oh, see how I had an error there in with a lowercase n? So distance in miles times how many feet in mile. Now make sure you spell that right. If you don't, you're going to get an error. So sometimes you can, or I would just, if it's a long variable name like this, I would copy it, Control C, Control V to paste it. Now, I question my math sometimes because I'm normal. I'm a human being. So even though this program is short and we have one calculation, I want to do a walk through my program to see if it's right. So if I have 10.5 miles as my input, and I multiply that by 5280, then that should be 55,440 feet. Well, let's see if our program does that. How we do that is in process output. So I'm going to say system. I'm going to add some spaces. So out.println, and I'm going to add a blank space. It'll kind of double space my input. I'm going to then say system.out.println, because I want ln remembers the return. You are going from point A, whoops, I forgot my plus point A, which isn't addition, it's concatenating, joining. You are going from point A to plus point B. So it'll say you're going from home to GRCC, or whatever, from Meer to home. Sorry, I was thinking what else I wanted. I don't think I want anything else. So I'm going to end that like that. And then system.out. I'm going to just say distance in feet. Well, distance in miles first. And I'm going to do a plus, and then distance in miles. Close my parentheses. And then system.out.println distance in feet. No spaces in variable names. I can't believe I just did that. I'm getting tired. Okay, and that's all my output. That's all I requested. So I'm going to compile. I am going to run and see if I enter 10.5, if I get 55,440. So I'm going from GRCC to home, and it is 10.5 miles, and I go 55,440 feet. Oh, I didn't put a space here before that too. That would be right here. Space. Okay, now I mentioned print F. We'll cover that later. We've been talking too long. You can use it in assignment 2 or not, and reference that 1015, page 1015 in your textbook. I'll take that requirement out, so it's optional. But if you have what you need to do with a pedometer calculator, make sure you use doubles so it calculates decimals. Otherwise, it'll truncate it. So sometimes when you run your input, so say I'm going to run it again, and I'm going from my home to Owen's school, and it's 3.8 miles. Sometimes if you use, so 3.8, I just want to make sure that it's not truncating it, because sometimes if you use an integer, it'll make the answer an integer. But see, we have this 0.0, so it looks like we're right. 3.8 times 5342. Is it 5342? 5280, sorry. This is called desk checking. That's the word I was thinking of. 3.8, we're checking on the desktop, maybe, times, how many? 5280. 20,064. Good. If you would have made this integer and an integer, you're not going to get the 0.8 or the 0.0. And if it had a decimal, like if it were 20,064.5 feet, then you're not going to get the exact answer. And that would be a problem. So what you need to do, read in the book about doubles and floats, and check out printf in the back of the book on page 1010. And as we do our next assignment, we'll do more on formatting. But in the chapter 2, it does briefly address it on how to get the decimal value. What you need to do with assignment 2 is make sure, desk check it, pull up your calculator, and make sure you get the proper output. I'll add some samples there too. All right, so what you need to do before you turn this in, copy your sample output. You can give me, whoops, run IO. Here's my last one. I want to see that, or whatever you entered, right here. And then you can save it. Make sure you save it. And when you are in Blackboard, I have to post the assignment in here. Remember, you click on the file and upload it. So this is Code with Me 2. Thanks for sticking with me for the whole This is Code With Me 3, in Learning Module 3 for Chapter 2. So thanks for sticking with me for quite a while. I hope you learned a lot in this chapter, and the assignment 2 will be easy for you to complete now. Have a great time.